How's it going, everyone? Welcome on in. Happy Tuesday. We're going to be continuing our transformer. We're going to be building ChatGPT, a little mini ChatGPT. I'm really excited about this because we have successfully got started yesterday building our own custom transformer. We got started with it. We have not completed it yet. It seems like I did a little studying. And I'm going to try to do all of this as much as I can from memory. And I will draw a diagram. I think drawing a diagram is going to be really useful. And then we will, obviously there's already diagrams right here. we've got the paper right here. I'm going to draw it so that way it sort of solidifies more in my mind. And then I think that will be a good start to the day. We've got a lot of diagramming that we can do here. And then we will get into with the coding. And I think, what? I found a little, there we go. I've got to update that right there. Okay. So we've got our dictionary, which is basically our vocabulary, our dimensions. We've got our projections, including an output projection. Then we will multiply query and key together with a scale that divides on the dimensions based on the number of heads that are being used. And we're going to start off with one head, and then we will maybe upgrade tomorrow if we have time to have two heads. I think that's a good plan. I like that approach. Good plan. I like that idea. Okay, so let's start off by drawing some items here. So let me see here. Number 2, let's go and draw our input. So this is, let me see. Oh, maybe we'll start with the sentence, the cat. Oh, what we could also do is split up the tokens so we can see the cat was happy or something like that. I like that idea. All right, the cat was happy. That's our input. Was happy. There we go. Input text. Then we move to the next phase where we split those up into tokens. All right, so let's go tokens. So we're going to split them up into individual components. Basically, we're gonna pivot them. The cat, the chat. We're gonna say chat. I like that better. Was happy. There we go. Okay. We're gonna the chat was happy. Let's say chat there as well. All right. Here we go. Okay. Then we need to convert those into tokens. So that makes, basically, we're going to vectorize. But I mean, this is not vectorized. Well, technically it is vectorized. You're converting the string into a number, a bunch of numbers. So we go into the next phase here. We're going to convert these into a bunch of numbers. So we'll just say, like, for example, keep it simple, 1, 2, 3, and 4, right? Because this will be the index. So the number 1 will be associated with the word the. Right, so we've got the chat was happy, right? So we got 1, 2, 3, 4. So far, so good. Then we need to embed these with an embedding model. The embedding model is just a matrix, and you select the row in the matrix that is assigned to the index. Really simple, you guys. Okay. So let's go on to the next phase here, keeping things simple and easy. Here we go. So that is going to be multiplied here. Here we go. And this is the embedding layer. So let's just say it's like 0.1, 0.5, 0.8, a whole bunch of different rows here. Let's copy and paste this. So this is actually, you know what? These are all different numbers. So let's make it a little bit more easy to see here. 0.3, 0.1, 0.8. Right. Let's do a 2, 5, and a 2 again. All right, let's do a 3. 0. Let's see here. Hey, Derek, good to see you. Welcome on in. Happy Tuesday. Hope you have a good day so far. I'm going to diagram the transformer really quick, the full end-to-end flow. For the most part, no, we'll like get to the higher level stuff, and then we'll plop in some easy modes like the attention layer, things like that. So this is the embedding here. This is embedding. This is going to help me understand it a little bit better. Very good. Made lots of progress on a project you did. Nice. That's great to hear. Very nice. Always good. Progress makes things feel good, right? I like that. It feels like product. When you say you feel productive, it's a good feeling, right? It means you're happy. It means you're happy. That's the project that you're working on right now. That's great. Let's do 7, 0.2, 0.9. Okay, here we go. This is good enough. All right, so we've got some numbers here, right? This is a matrix. This is the embedding. It's just a matrix, simple, easy. And then we take each of these numbers and assign it to the index based on this array, which sounds really simple. Is it really simple? Yes. Yes is the answer. It is very simple. So really, this will be, let me see here. So what we could do is to make this a little bit, no, we'll just keep it simple. So then we just split these out into separate rows essentially at that point. So that's going to convert into this, which is just a simple pass through. So let's do like number 2, yeah. So you can see here we've got 4 vectors, and this is the embedded output from this embedding based on these tokens. Then we do some positional encoding, which is going to assign a bunch of additional properties that we can essentially it's just a number, more numbers is what it is. We got even more numbers. You thought we were done with numbers? We're not done with numbers yet. We got quite a few numbers. All right. So let me see here. Where are we with our numbers now? So then we do positional encoding. So this is positional, all numbers. Exactly, Derek. They're all numbers. Every single, all of them, all are numbers. So this is the output from the embedding. From embedding, there we go. Output from embedding. We do positional encoding, which is just going to be another set of numbers. A bunch of more numbers here. How's it going there, Joseph? Joseph, good to see you. Welcome on in. Happy Tuesday. Good to have you here. Thank you for clicking the hi button. We're just currently building a mini ChatGPT is what we're doing. We're building a mini ChatGPT. So we've got some positional encodings here, which are going to be just more numbers. So we'll say 1, and we'll say like 0.8, 0.1, something like that. And then we just continue. We wrap these up. I love the title. Hey, nice. Good to hear it. Yeah, we're doing that right now. We're currently, I'm diagramming what we're going to do. We've got some of the code up here. So we already got some of the code started. And we're going to be diagramming first. And then we're going to see where we're missing, because I got some of the projections set up already. So things like we don't have yet are the attention. We have not fully, well, it looks like I actually got pretty far on this attention yesterday. I almost did. Okay, so we've got the attention that we need to do. We need to do the forward pass. And then I think we need to figure out a way to stack it. Because you can stack multiple, at least attention transformers. So yeah, we can stack them. Obviously, we could do multi-heads. And that would be something else that we're missing. Will you implement KV cache? Ooh, a key value cache. Yeah, it's a good idea. I didn't even think about that. Interesting. Yeah. So you could. I guess I need to understand it a little bit more to figure out where the numbers are going to be the same, where they're cacheable. Right? You could snag out at the embedding and positional layer. You could cache those. And through the projection, I believe you could also pass through the projection as well and cache that output, because it's going to be the same. Depending on, and then you can add more tokens, and only the added tokens will be shifted, right? And so you'd need to project through those. And what would that look like? See, that's what I'm wondering. Derek, have you implemented a KV cache before? I need to think about where. It's only necessary for inference, though. Since training, you dump it immediately after training it run. Oh, got it. Hey, Cyber Potato, good to see you. Welcome on in. Hope you have a good Tuesday so far. Let's see here. Let's go to our Discord really quick. copy a link and say, I forgot to paste the link here. At everyone. There we go. So that way y'all know we're live. Okay. There we go. Good. Get my windows set up there. Yeah, so that's the plan. So a KV cache is actually a good idea. So let me add some to-do items for the Steve Informer. All right, so to-dos. All right, here we go. So we could do a KV cache. We could do multi-head, which is nice because the multi-head's going to give you a little bit more attention on different tokens, right? A little bit more attention on different tokens. This is like obviously only good for inference. Good for inference. And then we've got to do, we still have to get the attention finished. We have to finish the tension. Then we have to forward pass. What else? Okay. Yeah, I think it's about right. Okay. So let's keep going with our diagram here really quick. So we got some positional encoding. We're just gonna make this simple. Let's see here. All right, easy, simple. Then we just add these together. So this is a bunch of addition, right? So we can do like a plus sign here. A bunch of plus signs. Yeah, that's all it is. You're just adding them together. And then we do some more math, and then we basically get this. We get the final token output embedding plus positional encoding. And then we've got that input. We're good to go at that point. Yeah, the way you did it was reverse VRAM at the beginning of the chat, and then particularly appended the value as the input that came in. So there would be no need to resend the whole conversation. Oh, Dina. All right. That's pretty clever. I like that. That's a good way to go about it. Basically sampling how LLM works. Yeah, we are. That's what we're doing. You got it. That's exactly what's going on. So we're going to do a quick little diagram here. We got the chat was happy. We tokenize it, 1, 2, 3, 4. Then we've got an embedding layer, which is, you kind of think is a bunch of random numbers. They are learned weights eventually. We're not in the feed forward once we do back propagation. Hey, Needswa, good to see you. Welcome on in. Happy Tuesday. We're continuing on. So what I'm doing, right, we're learning the entire architecture of a transformer. So one of the ways to learn is to do a full end-to-end diagram. And that's what we're doing right now. I'm sort of putting on the screen all the pieces that we need to make it work. Happy Tuesday. Yeah, it's good to have you here. Welcome on in. So we've got our embedding. We got the output from the embedding, positional encoding, which is just, a bunch of what you could do a whole bunch of different kinds of positional encoding. Basically, it's a representation of where each token is in its current position. So you've got like, token 1, token 2, token 3, token 4. You encode it differently based on its position. So each of these numbers really should be different. Let's kind of put some a little bit of a contrast there. This is really about contrast. There you go. A little bit of contrast there. Sounds great. Didn't expect you to end the live stream early yesterday. Oh yeah. I had to go. I've got a 9:30 as well again today, and then it gives us about an hour and a half. So we should be able to stream for an hour and a half. Are you busy? Yeah, I'm busy. My calendar is pretty full. It's pretty full, which is good. It's good, right? Good that we're busy. All right. So positional encoding. Yeah, so I've got lots of meetings throughout the day. So I'm trying to get the stream at a regular time in the day. And I find I was trying to do the afternoon streams, and I was running into a lot of meetings. So I was jumping around. And so now I think earlier morning is going to be a lot better. I see, fair enough. Yeah, there you go. Yep. Absolutely. So positional encodings, and then we get our final output. Let's just copy and paste these guys right here. So we know right here, copy, undo, paste. Oh, wait, did it go did it go somewhere? Did we get it? Or did it just, where did it go? All right, let's copy, paste. Yeah, there we go. Now we can adjust those numbers. Hey, top 1% engineer, good to see you. Welcome on in. Happy Tuesday. We're going to be doing the ChatGPT. We're doing mini ChatGPT today. We're doing transformer end to end, currently diagramming it. Then we've got most of our code already kind of started here. And then we are going to write it implement it and run it and start training on it. Then we're going to train it on its own code that was built. So all this code right here that was run, we're going to train the model on the code itself, and we're going to have it print out itself, and then we're going to have it run another instance of itself. All right, we're gonna have an AI birth an AI. That's what we're gonna do. Can you share in GitHub? Absolutely. Yeah, absolutely. Absolutely. Well, do we have this on Git status? Yes, we do. So git add transformer, git commit added to-dos. Okay. And then git push origin main. And then let's see where we're at here. Vi.git config. It is right here. Okay. So let's grab this. Transformer, GitHub. Okay. Oh, wait, that didn't work. We're github.com/. There we go. All right, let me paste this into our Discord really quick. So I'll go under link share. Here we go. Perfect. There. It is in our Discord under link share. Mini GPT. Wow, sounds so cool. I know, it's going to be fun. It's going to be fun. I'm really excited about this. Okay. So let's see. I want to. Here we go. Okay. So let's do a smidgen of math so that way we can get these numbers correct. So this will go to 2. This will go to 1.13. Yeah, I think that's 13, right? And then this goes to 8. And then this is going to be the same. Let's see here. What is this? 3. All right, so 3, 8. This will be 11. This will be 2. This will be 8 plus 8, 16. And then we've got 3, 8, 5. That's another 13. 13. And then we've got 4. Oh, 9 plus 8. That will be 17. 17. Then this will be 3. Then we've got 8 plus 7 is 15, right? 15. There we go. Perfect. Okay. So now we got our output from our numbers. We've got all of the data. This will be the input to our query key value projections. Identical on all sides. So this will be QKV projections. We've got more projection layers. Basically, essentially more numbers. I'm just going to copy paste this to make it simple. So we're going to have 3 of these here, 3 projections. Although for performance, you can just merge these. So you've got query key. So you've got query, we've got our key, we've got our value, right? So 3 projections, kind of like convolutional neural networks, right? You got your filters, and then you split these up. So we're going to basically copy. So that is number 5. Here we go. Hold on, let's undo that real quick. Let's make it a little bit better. There we go. 5. All right. So now we've got our numbers. We're going to copy these so that way they each get a copy. They're going to be projected. Each of these matrices will have random weights. They don't show as random weights right now. I'm just not going to fiddle with it as much. And then we get some projected outputs that are more matrix. It's more numbers, even more numbers. So I'm just going to say a bunch of numbers. So we've got our output, Q out, and we'll grab this. We're going to simplify it a smidge here. Q out, and we go here, key out, K out, and V out. Looks good to me. Hello, hey, yeah, video games, good to see ya. Welcome on back. Happy Tuesday. Good to have you here. Hope you're doing good over there. We're just doing a little bit of quick diagramming for our code here. Then we will be on our way. So let's see here. Okay. Query key value, output, we've got a Q out, which are basically going to be more matrices, more numbers, right? We got even more numbers. Then we need to go into a multi-headed. If you want to do multi-heads, you can split these into heads. And then you can calculate attention across each of the heads. Right? You thought of a new meme? Oh, what is it? Hey, Kevin McAllister, how's it going? Good to see ya. Happy Tuesday. Oh, pretty cool. Are you making it from scratch? Yes, we are. We're doing it from scratch as best as we possibly can, right? So I've got everything in my head. I see the full end-to-end picture of a decoder. We could do encoder as well. A decoder only, you know, a ChatGPT essentially. We're doing a ChatGPT. Happy Tuesday. Good to have you here. Yeah, we're doing it. We're doing it. Yeah, we are. You got it. Kevin McAllister, you got it right. So we're doing a simple walkthrough real quick. Everything from memory. So we've got, you know, the chat was happy. We convert it into tokens, which basically you assign indexes to the numbers based on your vocabulary. You have an embedding layer that you just select the row based on the token number. Nice. Any idea on training it? Yeah. We're going to train it on its own text right here. On its own text. Right here. We're going to train it all on its own text. And then it's going to print out Python code, right? And then we're going to load it and have it train another one. And we're just going to put it in the loop. And it's just going to train and loop and output, train and loop and output. I know it's silly. It's a toy. It's a toy, but it's still pretty neat. It's a neat story. I think it's a neat story. And I'm pretty confident that we can make it work. That's so cool. I know, isn't it? I thought that was Chat's idea yesterday. They're like, hey, maybe you should have it train itself. I'm like, oh, we have to do that. We have to do it. We absolutely have to do it. How's it going there? Foodie. Hey, Foodie. Free palette. Oh, I see what you said there. Hey, Foodie. Good to see it. Welcome on in. Happy Tuesday. Good to have you here. All right. That's loop awesome. That's a loop. Yeah, it is. That Joseph, I think it's going to be a good loop, right? And it's just going to be an AI that retrains itself to create a new copy of itself. And it just keeps going over and over and over. I know, it's such a good idea. All right, now we need to do self-attention. So what we're going to do is I'm going to do like a self-attention here. We can also split these out into multiple heads. So when we calculate attention, we do attention across each of the heads. Right, each of the heads. So this is Q at K. You know, I guess you could say you don't need to worry about transposition there. This is going to be the softmax. So wait, here we go. Oh, we need to divide that by the SQRT of the dimensions in the head. So I'm going to call it DH, and then we atmult the vector or the value there. So here, okay. I think. Oh, and then we softmax the whole thing, right? Or no, we only softmax this part right here. So softmax, and then I think this is the full picture on the attention, right? This is full. This the full attention right there. I'm pretty sure. Okay. Yes. Here we go. Let me assign there. Perfect. Okay. So Q matmult K divided by the square root of the dimensions in the head, multiply the softmax multiplied by vector value. I think that's the full attention right there. I'm pretty sure. I'm pretty sure. And then for each of the outputs, if we have multiple heads, it's going to give us a bunch of smaller matrices, right? So let's just say a whole bunch of small matrices here. So that is number 2, bunch of small matrices, right? They're all the same size, but my drawing is gonna make it look like they're not the same size. And then we basically stack them or concatenate them, right, into one big matrix, like this, like that. Then we throw that through a feed-forward linear layer, which is another matrix. This will be concat of heads. Then this is a linear layer, like another linear layer, and then I think that's it, right? Well, I mean, I didn't include the mask, the attention mask, and I don't know where that goes. Where would that go? Where does the attention mask go? Do you know? Does it go on these here, on the query key and value? Somewhere along these lines, right? The feed forward layer as well. Yeah, all right. Yeah, exactly. So we got the feed forward. This is the feed forward linear layer, which is the final output, which is basically what we have here we've defined it as our output projection. Just call it output projection, right? That's the way to do it. Okay. The attention mask is on Q and K during attention. Okay, so it would be here. So we'd need to mask those guys before we... Now, here's the deal. Do we do that on a per head basis, or do we do that on the entire Q and K before we split the heads? Do we know that? Do you know? I know we could... we've got an example that we could look at to see for the mask itself. Do we do the attention mask before we make the heads or after? Because I guess it doesn't matter. The only thing is the mask is really going to take away a lot. It takes a lot away. And usually per head, I think. Oh, it is per head. Oh, really? Per head? Okay. All right. So then that seems fair. That seems more fair if you do it per head. Because if you did it for the entire Q and K, you'd be striking out a lot of zeros in there, and right, a lot of zeros, and a lot of the heads could end up with just all zeros. So if you do it on a per head basis, then at least every single attention calculation will have some value to it. Before softmax cloud head, is it? Okay. After, so before softmax, after. Okay, so it's in here on a per head basis. Q at K dot transpose. Yeah, we could say dot T. I think it's a good idea to say dot T. Dot T. Okay, for the transposition, RT dimensions, or square root, right? Square root of dimensions. Reshape should be batch heads, sequence length, and head dimensions. That makes sense. Yeah, that makes sense. Okay. After Q and K are mat mult and scaled, but before softmax. Okay, so right here. So we do the mask here. Mask. M-A-S-K. Right here, like this. So let's indent that. All right, so we do the attention mask. A-T-T-N mask. All right. That looks good. Right there. Okay. Precisely. Nice. Thank you, guys. We're learning together. Well, you already knew this. Okay, right? You're helping me learn. You're helping me learn. This is great. All right. Softmax, tension mask, Q, K, T, square root of the dimensions that are currently inside of this head. Right? So the dimensions in this head. And Steven, the linear projection from the attention forward and the feed forward are separate. So you're saying over here, these are separate? The linear projection from the attention forward and the feed forward are separate. So I've got them as one layer. I was A and Z were the same thing. You're saying that they're separate? Okay. So there's basically two of these? Is that what you're saying? Someone has already made LLM from scratch? Yeah. Someone has, and I think more than someone. Yeah, exactly. I wonder who that is. Got quite a few someones in here. Someone has. Yeah, exactly. Usually the final feed forward goes from embedding dimension to 4 times the embedding dimension back to the embedding dimension. Oh, okay. So this part right here, I need a little bit of a little work on here. So what now? He can do it? Yeah, Cloudhead. We can do it. We can do it. So I've got part of it written here. We're going to finish it. We're going to write it up next. I'm seeing people in the chat has already made LLMs. Yeah, exactly. Somebody has been making large language model. Exactly. We're talking about Derek and Cloudhead, or Dina. True, yeah, you sure as well. You have as well. Yep, exactly. Because everyone is so knowledgeable. Yeah, I know. Y'all have already done this. You've already done this. I only did this a couple years ago, and I'm remembering it. Although I didn't do it completely, because I've missed a few things. So it'll be 2 separate linear layers with an activation in between and some dropout. Okay, got it. Okay, so let's copy and paste this bring it over here. All right, so we will do what's the difference between feed forward and linear layer? I mean, I assumed it was linear. All of them are linear, all numbers. I did it always way too complicated and gave up. Oh, you did? It is pretty complicated. And the good news is you can do what I did, where I simplified some of the steps and it still works. It still works. AI algorithms are surprisingly forgiving. You want to optimize for smoothness. You only have a finite number of bits when you're training your AI for each of your parameters. The floating point numbers, they don't assign all of the decimal precision. All the bits don't get assigned to the decimal precision. You get some of them assigned to full numbers, right? And if you're mostly working in the decimal precision, you're throwing away a lot of bits. So I think there's something called like B-float that gives you more precision in decimals. So it works a little bit better that way. Is it similar to Andre Karpathy GPT? Oh, hey, yeah. Good question. Thank you for asking. This would be similar in a way, I guess. Maybe. I don't know. We're going off of the Google paper. That's what we're doing. Feed forward is made up of linear layers. Feed forward is like another network. Oh, so a linear layer, then GLU, then a linear layer, and then dropout, for example. Oh, made up of linear layers. Feed forward is like another network. Okay. Oh, Derek, that is making complete sense. I completely get it. I get it now. You've made it. All right, that makes help. Yeah. Feed forward can be a single linear layer, but multi-perceptrons. Yeah, MLPs. Multi-layer perceptron can have numerous linear layers with activation. All right. Hey, Horse Hobbit, good to see you. Good morning. Welcome on in. Happy Tuesday. We're creating ourselves a mini GPT. That's what we're doing. So we currently just finished nearly finished our diagram. Where is it at here? So we've got a feed forward, or I guess maybe an MLP. Then we've got a linear output, maybe. Linear layer for the output projection, and you've got a feed forward, which is going to be some linear plus the activation. He's shown in simple Python, no external libs, like not even NumPy. Oh, that's okay. So it won't be. We could do that. We could, absolutely, 100% we could, because I've actually done it before on stream. On previous streams, we've done that. One of the things that I was missing out on was a framework like PyTorch. So the way I learned AI was before these frameworks became released, before they were released or even popular. So I had to do all of it by hand. There was no other option. The frameworks like PyTorch and TensorFlow with Keras and JAX all came out, and they're all fancy, and I want to learn how those work. I want to learn how those work. So we're going to be doing it in Torch. Yeah, exactly. Hey, Cloudhead, yep. Or do it in a Torch. You got it. Yeah. So that's the plan. That's the plan, you guys. All right. I'm changing up some of the music here. Is this good? Is this good? All right, we're going to go with this song. Okay. Feed forward, which is so like Derek was describing, we've got a sort of a linear, and then a activation, and then we do that again. So another linear, another activation. It's like a bunch of these in a row, maybe. Linear activation, something like that. Then we got a linear output for the projection that matches the vocabulary, right? So the output has to match the vocabulary. And then we did it. Look at that. That's pretty straightforward. Look at this. Zooming in. The chat was happy. Tokenize it. Convert it into numbers, right? Indexing based on your vocabulary. Capture your embedding, which applies a simple index lookup to your array, your multi-dimensional array, which basically selects the row. So 1 becomes, 1, 3. So it's a really simple pass-through. So it's kind of like this. So that's right here, right? So each of these. And then it looks the same on the other side for the most part, right? It's a direct copy of those rows. Then we apply positional encoding. essentially, which you just add it, right? And your positional encoding can be whatever kind of positional encoding that you want. There's a lot of different varieties, right? You could do a whole bunch of different ones. And this positional encoding is one of the limiters on the maximum number of tokens. Otherwise, you could essentially have unlimited tokens, I believe, in a model. I'm pretty sure. I'm pretty sure you could. Generally, the feed forward is only linear activation, linear dropout sometimes. Oh, hey, Cloudhead, thank you. All right, let's adjust that. All right, so then we will do like a dropout here. Dropout. Let's see. We'll just, yeah, activate, linear, and dropout. Okay. Thank you, Cloudhead. That's appreciated. The background music plus this diagram is absolute cinema. Is it really? That's great to hear, Joseph. Thank you. Okay, so that's the feed forward, and then we get a linear output with no activation, which can convert whatever dimensionality we have here back into our original token, a token count, I believe, right? Okay. So I think that's it. I think we did it. We succeeded. Could be unlimited based on available VRAM, but context rot would mess it up. Yeah, that's right. That's a good point, Derek. Yeah, at a certain point, the scaling factor of the attention and the heads could run out, could exhaust, right? And then because maybe you'd have more dimensions on your embedding in that case, right? You could do more, and then you would also need more positional encodings to be able to satisfy larger contexts, which that one's easy. Like, oh, that's a freebie right there. That's a freebie. Though you could keep generating over and over and over, and then eventually, yeah, it loses unless you train it. So you need to train it on those later contexts, right? Got to train it, you guys. Okay, here we go. We did it. Look at that. There's a transformer. And then apparently you can repeat part of this, right? So you've got after you've done your embedding here, you can repeat this segment, I believe, right? So let me do a repetition here. So on this part right here, you can repeat. And I think that's by design. You're supposed to. You're supposed to repeat that right there. True, it depends on how you freely want the earlier information to propagate, which is a bit technical. Oh, yeah! That's a good point, right? So you've got all this context, a whole bunch of tokens, like say 500,000 tokens. So many tokens! What do you do with it? Well, you need to be able to train the model to have attention to attend on the output for whatever you're targeting. So if you target the next token, you need to train it, probably through reinforcement learning, on those later tokens. So it just becomes a scaling compute cost, right? RAM, memory, and compute, right? GPUs. You can only compute so much. So you only have so much time to train it on. Also, with that later context, there's an explosion problem, right? Because you've got all the possible amounts of information that could be in that later context window you'll have a difficulty training all the permutations because it diverges so quickly, right? It's an explosion of divergence. Which board is this? Oh, good question. Which board? This is called Excalibur. It's called Excalibur. Here we go. So these layers can be repeated multiple times. And then boom, ChatGPT, you guys. ChatGPT, we did it! We have to build it now. Let's code it up. Sliding attention windows could help, but it would forget earlier inputs. Ah, that's right. That's right. You could do that. You could do that too. That's a good way to do it. I like your thinking, Derek. I like your thinking. So I tend to use register tokens, aka attention sinks. What is that? What is that? I'm curious. Prepend to the sliding windows. Okay, so you tend to use register tokens, attention sinks, register tokens. Okay, so you've got some special tokens here is what you're saying. You've got some special tokens. So something like RGS, wait, register. I don't know, you've got some sort of special token there. Is that what you're saying? Does Excalidraw use PubNub? Derek, I don't know. I think it's a single user draw. Although if they did add PubNub, it would be multi-user collaborative, right? We'd be able to see what we're drawing. We could draw on the same canvas at the same time. We could do that. So I'm thinking, you said you've got some special tokens, is what you're saying, Cloudhead? Also, I'm kind of curious. Go to channel, let me see here really quick. Okay. I was checking to see if you had a different name. Okay, yeah, I think we're good to go. All right, so let's do this with a single head first. Let's do it with single head. Multi-headed attention apparently is really straightforward because we can just reshape or create a new view. Hey, I was going there. Cardinal. Hey, Cardinal Erdem. Erdem, hey, welcome on back. Good to see ya. Happy Tuesday. Hi, Mr. Blum. Did you saw the Sam Altman's new tweet? I didn't. What'd he say? He said they want robotics technical member. Oh, really? And lots of people tell the new hype is humanoids. What do you think about the future of AI? We're going to robots. We're going to go to the Matrix. The Matrix, right? The lore of the Matrix, the movie, right? The Matrix movie, 1999, right? Simulation for all humans, right? However, how did we get there? Well, it turns out we gave birth to AI, and AI includes robotics that were living among us, doing all the work for us, and then eventually they got smart enough to have ambitions and desires, right? And they went to war with us. So yes, we're on the right track for that future, I guess. I don't know for sure. There's special tokens that the attention module applies greater attention scores and can hold context semantics for earlier. Interesting, Cloudhead. Interesting. Very interesting. All right, I somewhat understand that. I somewhat get it. So when you say greater attention, I just think bigger number. That's what I think. The tokens with bigger numbers. Hey, Cloudhead, thank you for subscribing. I appreciate it. That's really great. Oh, yeah. You joined the right channel for software engineering. Thank you so much. Yeah, so I don't know. For those of you who are new here, my name is Stephen Blum, CTO at PubNub. We raised under 34 million, Series E, 1 billion devices on my network, usually like mobile phones, that communicate. In-app communications, what we do. Got 68 patents. You can see them on my LinkedIn profile. They're public. I made them, obviously they're public, right? You could have protected patents that are behind. These ones are free and open. Free and open patents. Yeah, attention sinks would definitely help. I wonder how the big labs handle this with their long runs with models. Yeah, I'm curious too, right? They're keeping all those things secret now, aren't they? The ones which take multiple hours. Yeah, there we go. Multiple hours. All right, so then we need a dense feed forward layer, right? So it's something where the model can start applying knowledge and learn from. So we need a like a feed forward here. So I was just thinking a simple linear output projection was all we needed. Nope, apparently we need more than that. Get a bit more than that. All right, so this needs to be a to-do here. Got to do that. So feed forward, or an MLP basically with activation, probably like GELU. Probably do a GELU. I like those GELUs. GELUs are pretty nice. I like GELUs. I know everyone's like, linear electrified unit. Well, let's do the right? RELU, the rectified linear unit. I like the GELUs because it's got a swoosh. It's got a little bit of swoosh to it. So you get some values in the negative versus no negative numbers at all. Just prepend the attention sinks to the sliding window. Okay, to the sliding window. Okay. And it will manage it for you. Oh, really? The model figured out how to use them eventually, but that's only for sliding window attention. Got it. Okay. So you've got a fixed window, right? And you basically have a bunch of words on the screen. And so here's the first window, right? And then you slide it over by another, right? and you do one at a time, right? So you keep going. Well, the window is fixed though, right? So if we were to if we were to represent that, we'd say cloud head, right? Let's say that's the word, and then our window is really small, just as a comparison, right? So we have a window of like, I don't know, 3, something like that. So we'd say the first window would be CLO, the next window would be LOU, and then OUD, then UDH. You get the idea, right? So we're sliding over cloud head. This. Something like that. So these are the views that we're getting. And then you're saying that you appended some sort of extra higher value token. What are you doing? Oh, we're making ourselves a mini ChatGPT here. Yeah, you use the AI products you probably have to build something for you. Maybe a doc, write some code. We're building that right now. We're doing it. We're using the attention's all you need paper, and we just finished diagramming our plan right here. Look at that. We got our plan. We're good to go. Language modeling. Yep, that's exactly it. 10H and value or legacy. Most labs go for GELU. Oh, they do? They do GELU? Oh, wait, that's great. I'm like, I like GELU better. Oh, they agree with me. That's great. It makes me happier. I like the GELU. The ReLU, the rectified linear unit, is great. It's fine. It just throws away so many bits. It's like, it throws away so many bits. It's like wasteful. We need to leverage every bit. See, that's one of the problems. One of the problems with today's AI models is most of them are relying on wasting bits. And for those whole numbers, the integers, there's a lot of bits that just get thrown away, right? I think we should use all of them for floats. Maybe like 3 or 4, right? 3 or 4 for non, and then we just convert on the output after softmax as an index. You're fine. You just keep everything in float. That works. It would take billions of tokens, right? Before it gets it. Oh, would it? Would it take that many tokens? Yeah, but I like the graph for 10H is what I mean. Oh, I like 10H too. I love 10H. I remember when I was first getting started writing AI, and I'm like, oh, let's try sigmoid. Oh, let's try. What is that? 10H. Let's try. There were some other ones in there. But sigmoid and 10H were the ones that I would be using. And I like, sigmoid was fine. However, I always found that 10H performed so much better. The problem is, of course, 10H is computationally expensive, right? And so everyone's like, oh, let's use radioelectrified unit. And I tried that, and I'm like, I get worse results. It just happens that it works better if you scale it up. It works better if you scale it up. You remember doing object-oriented programming exams? It was fun. Was it? Yeah? Object-oriented programming. It was pretty good. For sliding window, it's best for larger context anyway, which generally needs more training tokens. Also, the 10H graph is brilliant. I agree, isn't it? It's so good. It's the best. It's the best. I love it. 10H would be my preferred. That would be a weird question, but I can't understand naive Bayes algorithm. When the Bayes, how do you say Bayes, right? The probability comes in, my brain flies away. I cannot intuitively understand it. Let me see here. Let's see if we can visualize that together, you guys. Gemini. Let's see. Let me see. Graph it. Okay, let's take a look. What is this? Common Core Mathematics. Wait, what? Is that really what this is? Hey, Matchstick, good to see you. Welcome on in. Happy Tuesday. Hey, dude, how you doing? What are we doing today? We're doing good, and we're creating our mini GPT, right? We're doing mini GPT. So we already diagrammed everything that we're going to plan to do here. Start with the sentence, convert it to tokens, embedding, blah, 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 the self-attention, all the way to the feed forward and the final output. Happy Tuesday, Steven. Good to have you here. Naive Bayes is like, if I have X, what's the probability that Y is there too? That's actually good. I need to learn about this. I need to learn about it. Maybe AI is the last stage for understanding something very intuitively. Are we at the forefront? Is that what you're saying? We're at the forefront? Do you make enough money in your profession? I don't know if you get into CSAI related. Yes. So we are comfortable. Yeah, this is my company right here, PubNub. I'm the CTO. I started this company many years ago with Todd Green, my co-founder. We have 134 million raised at Series E, 1 billion devices. We are still going. We're doing good. We've got a lot more to go. We're not done yet. And a lot of my days I want to spend learning and evolving AI. Obviously, right? Let's get into the algorithms. Let's fully understand them and become experts. I want to become an ultimate expert. My expertise in my decades of computer science and having business is in communication, right? That's what my company does, PubNub. We're an API that provides in-app communication. So you have all the top 10 apps on the App Store all have built-in communication, like chat and on-demand order delivery, multiplayer gaming, those sorts of things. That's what my company provides. That's what I do. Okay, if you're good enough making AI systems, pace, loads, yeah, exactly, Cloudhead, yep, that's the new way. Remember, it was all punch cards, and then we went to Pascal and Fortran, and then we went to higher level languages like Java and, JavaScript and then Python, and now we went to web dev, and then we went to mobile dev, and now we're in AI. Now we're in AI, you guys. It's all about the AI now. Matchstick, yo, what does PubNub do? Coolest CTO ever. Hey, thank you. Hey, that's great to hear. Thank you, appreciate it. All right, so PubNub, we are a communication network, right? Where we've got lots of customers. Telemedicine, that's also something we do. So when you talk with a doctor, that is powered through the signaling on PubNub. FinTech, you've probably seen those stock quote tickers like move up and down, right? That requires a streaming technology like PubNub. Chat support, delivery, multiplayer gaming, sports betting, all that stuff, you guys. AI systems, what to major in? I think so too. Let's see here. Conditional probabilities can be useful to understand how prior tokens affect the current tokens. Oh, see, you're up there, Derek. You got it, Derek. I don't know why. Whoa, hey. Well, you've got a good future ahead of you. If you are understanding this already, you're good to go. We're on the forefront. You're on the forefront, you guys. Do you use ADTS? What is that, ADTS? Is that abstract data types? Yes. Usually, yeah, I do. Don't you? I feel like decision trees are easiest to understand. It's either K nearest neighbor or decision trees. Those are between those. That's the one. What is KNN? Is that like clustering nearest neighbor, right? Nearest neighbor, right? KNN is nearest neighbor, right? Nearest neighbors, yeah. I know of it. I've used it not practically before. It's always if you don't understand a data set, it might help you understand it a little bit better. That's all I got. It can help cluster things together. Similar, so let's look at some images, right? You can see some patterns, right? Class A, Class B. It doesn't know what those classes are. It just can identify classes. K nearest neighbor, yes. Supervised machine learning model. Is it supervised? This is like an unsupervised one, right? This is unsupervised. Oh yeah, thank you. Basically, I predict a value based on the value closest to it. Yeah, yep, Yep, you got it. Do you need college to get your field? I'm self-taught CS mostly. Hey, me too. I'm mostly self-taught. You don't need it. You don't. It's can you do the job and be successful? That's it. That's all it is. You don't really, in computer science, it's one of those disciplines that does not mandate a college education, right? It's a self-taught. And I find often those who are passionate and they teach themselves often have the deepest understanding and are therefore have the highest potential for being the best contributor right? I think. I mean, I'm biased because that was me. That was me. I did that. Pretty great for both. Nice. You can use KNN for both unsupervised and supervised matchstick. Oh, really? I thought it was mostly unsupervised. Interesting. All right, we're getting it. Fair enough. True. CS is ridiculously fun. Nice. Very nice. Get ahead early. There you go. You're on the right track. You mean machine learning at least. Machine learning is very satisfying. Is easily the most interesting. It is, right? For me, when I was growing up, it was game development, which, is still like GPU acceleration and things like that because it was a lot of fun, a lot of visuals, emotional responses on gaming, right? Gaming was huge. A lot of people game. Everyone knows what a game is. Everyone's played a game or at least seen a game. So, assemble learning for the win. Ensemble. Hey, Clinker Place, good to see you. Welcome on in. Happy Tuesday. I mean, I'll learn what I learned just because it's so fun. Yeah, there you go. You're doing it right. You did A levels in CS. It was mad humbling. Oh, A levels. The A levels. Yes. Don't worry. There are lots of things that are complex in the world, and they will become revealed to you if you just spend enough time on it. That's right. You got to spend enough time on it. Your brain will figure it out. Your brain will absolutely figure it out. Time series forecasting is so underrated. Hey, something for your transforms. X, Y, X, and G, R. Thank you for subscribing. Appreciate it. Welcome on in. You joined the right channel for software engineering. What we're going to be doing is becoming experts in AI. We're going to go through the basics, and we're going to go through advanced stuff, and we're going to go through more basics again, or advanced stuff. We're going to be building a lot of things. Today, we're building a mini ChatGPT. That's what we're doing today. And we already have gotten started on it. But school courses are always goofy. Yeah, so the thing is, you're only going to get what the teacher's going to teach you in that class. You might not get all the details if you don't put enough effort in, which is going to require you to focus on what they want you to learn, but don't have enough time to focus on what you want to learn. So I feel like it's a detractor, right? There might be some benefit to what they're describing and teaching. It often can lead to demotivation, in my opinion, in some cases, right? Because there's like a really boring or something, or they don't present the topic in a way that's interesting, and it really actually is an interesting topic, and they just don't cover it in that way. Cool Connect today. Mario Shrini, good to see you. Happy Tuesday. Welcome on back. Not understanding exactly what AI was. So I just woke up one day and was like, I'm gonna fix this, bro. And you did it. You fixed it. You figured it out. Matchstick. Good job. Cool content today, Mario Shrini. I'm excited for it too. Yeah, we're building our own ChatGPT. All right. So this was the sliding window we were talking about. All right. Query projection. Let's do, for a feed forward, I'm just going to do a simple linear. We'll just do self.l1 equals a linear layer. Let's see how. And then we're just going to copy the dimensions, linear, and then we'll keep things in the dims, keep things simple. And then we'll do an L2. I think that's a good idea. And then we're going to have an activation, self.activation equals torch.gelu. I mean, do it like that. Is that right? Do you guys remember? Let's see here. Quit explit. I want Python import torch. Then I want to say torch.gelu. No, it's torch.nn probably. There it is, right there. Perfect. Okay. So we got ourselves an activation. We got ourselves the feed forward, and we got an output projection. Perfect. All right. We're making our way. We're making it work, you guys. You feel like people make AI sound way too hard? It's easy. I know, right, Matchstick? That's one of the things. It's the echelon. They're all saying, hey, look at all these fancy terms, right? You've got activations, and you've got projections, and you've got vectors and tensors and matrices. They're all just numbers, right? It's all numbers. Why do they have to assign all the gradients? What is back propagation? What's forward propagation? What's an MLP? Oh, don't worry. It actually isn't that hard. It's not. You're right. They add these layers of fancy words to make it feel like it's more than what it really is. They do. They really do, you guys. Like softmax. Ooh, that sounds good. That sounds really good. What is that? Well, it just turns out it just converts all the numbers in a set to scale to add up to 1. That's it. That's it. So you have a bunch of numbers and then you just scale them down proportionally. So that way, when you add them all together, they equal 1. You saw Android Karpathy's video on GPT and got hooked. Hey, nice. The courses are so narrow and focused. That actually is really helpful because then you can really laser focus on exactly what each of the topics is about. And then you can talk about some of the math too. Bro, you've been watching that video for a long time? Oh, really? Nice. It's hours, but worth it. It sounds like a good one. But I'm trying to finish this one and Udemy course first. Hey, nice, Matchtip. Schoolwork so boring now. I know, right? Regular school? Like, what's the point of regular school anymore? You don't need it. What do you mean I need to study what happened 2 centuries ago? Just let me make my models, man. I know. Luckily, I didn't take a CS in GCSE. I don't feel the pain. Bro, I'm in CBSE. All right, you guys. Wow. Wow, you guys. Did you go to college? I did. I did go to college for 3.5 years, and I almost got my bachelor's. I almost did, and I dropped out because I was like, hey, what am I doing right now? I've got a business, I'm making money, and I'm going to college. Sounds great to me. That's great to me, right? Except for then I was like, what would I do if I finished college? Well, I'd just continue on my business. Well, what would happen if I didn't graduate? Well, I'd, continue on my business. So then the answer was the same either way. So I was like, college is a waste of time. Even if I get a piece of paper, I'm not going to use it for anything. So then I dropped out. I dropped out, you guys. Don't follow my path though, unless you've got something better than college. That's important. That's important. Go to college next year. So this September. Nice. That's great. Yeah, I mean, you didn't even have large language models. Yeah, exactly. There were no LLMs back then. Even simple regression and classification models are just graphs, bro. They are, exactly. They're just graphs. It's all simple. CBSE is the Indian syllabus. It's bad. Oh, is it? Well, just picking your best one. Pick your best one. You've got so many options in life. Can't imagine. I'm England. Also, the money is always better path if you got something. Yeah, there you go. Hey, yes, Cloudhead. That's what I did. That's what I chose. I chose that. You got it, Cloudhead. Second gap year out of high, just self-learning a lot. Nice. YXNGR. You're on the right track. You're on the right track. Hey, Torva, good to see you. Oh, how much did you need to pay for college back then? It was not that much money. It wasn't. It was so cheap. It was cheaper than a car. It was cheaper than a car. And now college costs multiple cars, right? I think multiple vehicles. All right. So we've got our feed forward. We got our feed forward. Feed forward. We got here feed forward, and then we've got our output projection, and then we've got our output, and then we should have a softmax in here, right? Self.softmax equals torch.nn.softmax. There we go. And I believe we need to put that right here. All right, here we go. We've got our feed forward. We've got our self tension. And we've got our, so where would we put our dropout? I guess we could put our dropout like around here, somewhere around here. Second, let's see. This is the only live stream I actually watch. Is it, Matchstick? No way. That's great to hear. That's really good feedback. You spelled torch wrong, dude. Oh, I did. Where? Torch. Wait, T-O-R. Wait, I sure did right here. Hey, thank you. Thank you. Appreciate it. I'm like, where did I spend it wrong? Oh, there, right there. In the softmax line. Thank you, Matchstick. Appreciate it. Like, where was that? Where did that happen? No problem. Nice. Thank you. How long did your business take to build? It took, I would say, it's been over a decade, right? So over 10 years now. It's been over 10 years. To get it off the ground and started, probably a good 6 months. A good 6 months, I would say, right? A solid 6 months. And then it just took a lot of iteration because we started with, single region, single data center, low reliability messaging. So in-app communication, right? In-app communication. That made it really easy for on-demand driver. So you could order a taxi, or you could do chat. You could do multiplayer gaming, right? And then we started making money, started getting paid, started being profitable immediately, which is a really good sign, obviously, right? Oh, we're making a whole bunch of money. That's a good sign. You're surprised as to how this channel hadn't exploded yet. It hasn't. Oh, I know, right? What is the deal? Hey, don't worry. We're on the right track. We're partnered at YouTube. So we're a YouTube partner. We've got into the creator community program, the community creator partner program, which means that I've got a community partner manager. So that I've got a bunch of resources at my fingertips. So we're on the right track. And this is all while I'm also working at my business, working with everyone at my business. We've got a lot of things going on. So hey, we're on the right track. We're on the right track. It might take a little while. Also, I only just started streaming last year, so this is it takes a while. It does. It takes a little while. Okay. So we got our output projection. We're feed forward. We got our activation. So linear activate, and then dropout. Do we want to do a dropout before or after? Where do we want to do a dropout? Do you guys know? Do we do dropout here? Do we do dropout? Let's see here. On multiple, we could do multiple dropouts, or do we do it before active activation? I suppose it doesn't really matter that much because it can be the same thing either way. It's going to be a 0, so it doesn't matter, right? Dropout doesn't matter. Okay. Remember me when you're famous. All right, Matchstick. Yeah, absolutely. And you'll get there too. You'll get there too. You've got an early head start and you're making your way on the right track. Keep on learning. Keep going. All right, so attention. So did we do our attention yet? Let's see here. So let's do multiple attentions here real quick. All right, so I've got a self.softmax square root. All right, so that's part of the equation, right? Thank you. What does dropout do? Oh, dropout. Okay, this is really easy. All right, it's really simple. All right, let's talk about dropout really quick. It basically turns certain numbers to 0 with a random chance. That just is really simple, right? Random chance of 0. So say we have a bunch of numbers here. Let's take this. This is going to be, let's see if I can grab this here. Right, yeah, perfect, okay. So dropout. So we've got our numbers on our layer. So then you have a dropout layer that's going to say 10%. So say your dropout is 0.1, which is 10%, right? Equals 10%. This will create essentially a probability distribution of a random probability distribution that each of these numbers from your input matrix will get converted to 0. Apply dropout after feed forward. Use torch in sequential for those. Wait, Cloudhead, really? All right, so torch in sequential after feed forward. What do you mean sequential for dropout? Hey, Peace Lord, good to see you. Hello. Welcome on in. Happy Tuesday. Good to have you here. Why is it beneficial? The idea is it's regularization. So it allows your model to generalize. It's going to remove some of the data and make it fuzzy, because when you're training it, you basically want to train it with as much as possible on all the data so it has all the knowledge. I would say you should go back and retrain with a dropout layer enabled after. So you could do dropout and dropout. So that's why there's a percentage usually. So that way there's a random probability of dropout, right? So it'll turn some of these numbers to 0. So it might turn that to 0. It might turn this to 0, right? Just keep that. Or it might turn this to 0 over here. So basically that converts it to 0 on some of those things. The idea is that it will lose attention for those layers, or it'll lose like focus on those things. It basically turns those to 0 and allows the model to generalize. I think that's the best way to say it. Early? Yeah, we're doing early. Hey, we're good. We've got about 20 minutes left. We got 20 minutes. So that way, here's the deal. Your AI model is going to see data that it's never seen before when it's actually running during inference. And if you've generalized your model enough so everything's smooth, it allows your model to better predict the next token for things that it's never seen before, and it still gets a good, accurate output. That's why dropout is valuable. Build the feed forward as a sequence. Oh, there we go. Cloudhead, yes, okay. I see what, I know exactly what you're talking about. Okay, yes. Uh-huh. Thank you for the hearts, you guys. Appreciate it. So yeah, dropout. It's a regularization technique. All right, sequential. Let's do it. All right, you asked for it. We're gonna do it. Self dot feed forward equals torch dot nn dot sequential as an array. Pop this over here. Here we go. And then we're just gonna say activation. We get one activation here, and then we need to say some commas. There we go. Do comma there. Okay. JLU, linear, JLU, and wrap it in a dropout at the end. Dropout at the end right there. Dropout hub speed generalization as it prevents certain neurons dominating or something, I believe. It's not an array, it just uses normal brackets only. So you don't need it as an array like that? Okay. I knew it was, okay. And we also don't need to assign this here. So let's get rid of these assignments. There we go. Don't need a dropout there. Okay. There, perfect. And I believe we can copy because this is already an instance of, so we just paste that there. There we go. There, perfect. Feed forward, boom. How about that? Does that look good? I think that's good. Thank you, Cloudhead. That was really good advice. I like it. So I'm pretty sure that will do what we want it to do right there. All right, 15 minutes to go. We've made some progress. We've got an output projection. Okay, this is going to give us the potential. And then do we want another softmax here? Typically during training you do. On inference, I know you don't for sure. There's no need to have softmax during inference. However, I think we can keep it thusly. Okay. So now that we've got our model fully defined, let me commit this here. Git status. Where are we at? Git add transformer. We finalized mostly our model. Hey, how's it going there, Vivek? Thank you for subscribing. Welcome on in. Good to have you here. Happy Tuesday. You joined the right channel for software engineering. We're currently building a mini ChatGPT. We're going to train it on the data of the code file that is used to train itself. And then it's going to be able to create a copy of itself and then train that to create another copy. Is it worthwhile? There's no point. There's no point to do it. We're gonna do it anyway because it's nifty. You guys. You don't need a second activation? All right, whoops. Oh, so you're saying we don't need this. If that's the case, then we don't need this. We can just do this. How about that? Like that? That better? Derek, you're back. Hey, welcome back, Derek. Most neural networks use only one after the first layer, otherwise the extra compute outweighs the benefits. Also, the non-linearity is already applied by the first one. You did it! All right, we got our non-linearity right there. Right there. And so on the second output, we don't need another one here. Not necessary, because we already got the benefit here, so we could drop that. Nice. The PyTorch saga, yeah, it sure continues. You got it, Clinker Plates. Good to see you. Happy Tuesday. Wait, what was this called? I saw your name. Hey, Lions for Lambs. Good to see you also. Welcome on back. Good to have you here. Usually the linear layers goes to the 4 times the dimensions. Yo, so you want to make them bigger. You want to make them bigger, times 4. So we could do times 4 here. We can do times 4. All right, you guys. All right, you ask and you shall receive. There you go. So we got a little bit bigger here. Boom. Easy. Easy. All right. Then we output our final projection to the number of tokens. We should be good to go. I think that's it. Simple and easy. Can you discuss about your streaming setup? Sure, it's really straightforward. I've got camera. I've got a lot of lights all over the room. And then I've got a Shure microphone. The Sony camera. So this is the Sony camera right there. And then I've got one monitor. And here's the OBS right here. So you can see the OBS right there. Really easy. Really simple. Super simple. It was speech-to-text model for some Ghanaian language. The tests was the client got good. So hopefully we will move forward with it. Hey, Derek, that's great to hear. All right, progress. Oh, that is productivity. If you say anything, that's productivity right there. Not always it expands, depends on architecture. Dimensions can be increased or decreased. Ah, Conwar, all right. Good to hear it. So we could, it really depends. It's all about balancing those numbers, isn't it? We want nice and smooth numbers. Smooth numbers. I like smooth gradients, you guys. How are making sure the song plays without issue from YouTube? Oh, yes. So, we've got our curated playlist of 106 tracks that I found that are free, Creative Commons, and have no encumbrance. So, this is a very specific playlist that took me quite a while to figure out which ones are, and these are all in the YouTube studio. So that's why we got songs that are made for YouTube friendliness. You got it. Could it be GPT-2 and 3 used the 4X? But yeah, it's really your choice. There you go. We got a choice right there. Choice. You all asked for it and you received. You received 4X. There we go, you guys. Okay. So let me see. Did we do everything properly? Are we all good to go? Is this the way I want it to be? I think it is. I think we did it. So let's finish our our attention layer here. So we got to finish our attention. So we've got a query key, and this is typically, we could do .t, though I don't know if we need to or not, because the matmul already includes a transposition. It already includes one. So see, out equals, we're going to say out at value, like that. I think this is it, right? Is there anything else? Obviously, we're missing a mask. We haven't done that yet, so we need to do that. To do ATT and mask, attention mask. Attention mask. So we could have just like a pass-through mask here, right? Let me comment this out so that way I know here. So we're going to do a mask equals this. I've got an idea. Here we go. Let's do this. Out. We'll start with the mask. Perfect. Oop, whoa. I didn't mean to delete all that. There we go. Okay. So that's what we need. We need that right there. Hey, dude, I'm back. All right. Hey, Matchstick. All right. Well, come on back. Good to have you back. We've got about 8 minutes left. Then I got to go to a meeting. We'll go to the meeting and we'll be back tomorrow. Don't worry. We'll be back tomorrow. We're going to make sure that we finish this project. All right. Let me see if this looks good. So we've got our Steve Informer here. We need to do our forward pass. Let's do a return out. There we go. Looks good. Okay. So we'll do attention mask, and we also need to do, on our feed forward, we need to split the number of heads, right? So we could do, comma, heads equals 1 for now. Heads. Save that for future reference. Also, Stephen, which IDE do you use? Good question. This is Vim. So I use Vim here, and the answer totally, if you're going to get the full answer, is ghosty. Ghosty plus tmux plus Vim. And this is not NeoVim. This is just regular Vim. I find that NeoVim has a lot of fantastic plugins that I never use. I never use them. They're wonderful plugins that I never use. I only ever just need to edit text. The good news is, if I'm going to do anything more advanced that would take advantage of those amazing NeoVim plugins, I'm just going to ask Claude to write it for me. All right, I'm going to do Claude. Otherwise, if I'm learning myself, I feel like any of those wonderful plugins are just going to be essentially a hindrance to my learning. So when I'm learning, I'm going to type everything myself, right? Oh yeah, I forgot about our heater library. Our wonderful heater library, you guys. So we could use that as well to do some visualization. We should do some visualization there. That would be neat. We should do that. You recently added an AI code explainer in your NeoVim plugins. Mostly wrote it myself. Derek, that is fantastic. That is great because it gives you a much easier access to get answers for things that you're looking for really quickly. Really quickly. That's really exciting. I like that. You never need to leave your terminal. You can stay right there, or your IDE, whatever your IDE is, right? You see, thanks. I'm probably not gonna be able to switch because I'm too used to VS Code. Yes, use the IDE that makes you happy. That's all you got to do. You don't have to you don't have to hear like, oh, you should use Emacs. Oh no, you should use Vim. Oh no, you should use NeoVim. What about all these other fun? Like, no, just use whatever makes you happy. It doesn't matter that much because you only spend less than 10% of your time typing on the keyboard anyway. Oh, and to clear up from earlier, yeah, I looked at it again, and it's called Steve Informer. Yeah, Steven Transformer. You got it. Oh, wow. Look, we still have our assembly up over here. Our hello world from assembly. Where are we at? Where did we leave? Here we go. Yeah. Called it the Steven Transformer. Do the same thing. Yeah, there we go. Exactly. But your screen looks so clean, dude. Honestly, it's relaxing. Oh, it's so great, isn't it? Simplicity. That's the whole goal. I like simplicity. It's fantastic. I love it. I love the simplicity. Makes me happy. Got to do what makes you happy, right? Because that's what. Well, why else? What's the point? I think seeking happiness is probably, maybe is that the answer to life? Like the moment, like I'm always like looking around as like the moment that I find the answer to life. Like it's like, okay, you did it, congratulations, and then the simulation turns off. So I'm like, I didn't figure it out yet. Don't turn off the simulation yet. Keep it going, keep it going. I have more AI to do. Okay, so is this the full attention minus the mask? I think this might be full attention minus mask. And then we're only going to be doing inputs. We're not going to be doing an extra targets input. So TGT, we're not going to do that. We're just going to do regular inputs. 3 minutes to go, you guys. All right. So there's also a sequential in here. So now we've got our feed forward. Let's see if we can start constructing our feed forward. So we've got our inputs. Out equals, let's see here. How do we want to do this? How do we want to do this? We need to do embedding. Oh, so Do we want to automatically include an embedding in our transform? I think we might want to. We might want to. Shout out to Vim and learning those hotkeys. Yeah, there we go. Vim motions. Or else LOL. Anyway, yeah. Lunch over. Have fun. Sounds good. Line for Lamps. Thank you for joining for lunch. Good to have you here. Hey, Sergio. Welcome on in. Happy Tuesday. Good to see you. Good to have you guys here. All right. So let's do our next. So we're going to say, we're going to do these projections, right? I think we're going to do these projections. So let's do those projections. So we need a query, a key, and a value. There we go. That's what we're looking for right here. Let's get that initial setup going. And this is going to be our inputs. Perfect. All right, here we go. Perfect. Use the one we created last couple of streams for embeddings. Yeah, perfect. We'll do that. All right, perfect. And good news, I just so happen to have it right. Oh, wait. Oh, yeah. Oh, you know, I probably have it in another file somewhere. Let me see if I can find that. Because we built our own. Derek, you remember? You remember that? Yeah, we built our own. Okay, so let's grab that embedding. Where was it at? You guys remember? Let's see here. It'll be around here somewhere. Let's see. In here, right? Model. Maybe it's called model.py. Do we have embed? Here it is. Right here. There it, wait, but we also did low rank adaptation. So we need to just pull just the embedding is what we want. All right, so I suppose we could just copy and paste this right here. So we could let's just copy and paste this. Hey, Bonzupi, good to see you. Happy Tuesday, good to have you here. All right, let's do it. Copy, copy, copy. And then we're going to go to, where is that at? Is it here? Yeah, Stephen Former, perfect. Okay, let's do our embedding. Embedding. There we go. Paste. Perfect. All right, so we do have a meeting that I have to get going to, you guys. We will continue this tomorrow. We were successful at doing a full walkthrough on what our transformer is going to look like end to end at the beginning of the stream here. And then tomorrow we'll be able to stream a little bit later. The Monday and Tuesday we had a lot of meetings, so that means that we got to get going. Yep, it started right now. I got to get that meeting started. Got to head to it, you guys. So let me commit this really quick. See, CD. What is my current working directory here? Transformer. Okay. CD desktop. It's called Transformer PyTorch. Git status. Git add transformer. Then we are going to say we started the feed forward. Finished attention. Mostly we finished attention. Push. Boom. Good to go. All right, you guys. Thank you so much for joining and helping me out today. You guys, it was so much fun. Matchstick and Derek. Thank you, Derek. And Cloudhead. Kunwar as well. Nitwa. Y'all guys helped me so much today. Good to have you here. Clanker Plays, Bonzupi, Sergio, good to see you. Hey, David, good to see you as well. Have a good rest of your day. Sergio, thank you. Bye, everybody. You are very welcome. All right, thank you. Hey, Nathan. Yes, Nathan, thank you so much. All right, have a good rest of your day, guys. I'll be back tomorrow. We'll be able to stream a little bit later tomorrow as well because I've got a little bit longer segment in our meeting schedule. So we'll be spending more time on building our ChatGPT. We're going to build it, and it's going to train itself to build itself and then retrain itself in a loop. We're going to do it. It's going to happen. All right, you guys, thank you so much for joining. Bye. Bye, Nathan. See you guys. Thank you.